Hello everyone, welcome to the webinar. So let's start the webinar. So hello, I am Anmol Saxena, Technical Support Engineer from Midas IT. Welcomes you all on today's webinar on seismic design of RC building using Midas Gen as per IS code. Okay, so this is my profile. I have done masters from SVNIT Surat, and I like to collaborate with many building and bridge engineers globally by providing the expert guidance and technical queries and conducting workshops related to structural design in Midas software solutions. Okay. So for the today's webinar, this will be our content. First of all, I will be introducing you to Midas family, and then we will see some application area of Midas Gen software, and then we'll go for quick demonstration as well of the software. Okay. So in between, if you have any doubt related to the webinar, you can just note it down or you can just place it in the chat box or the question box. And then we will take all your queries at the last. Okay. So no need to worry about your queries. We will be taking it after the session as well. Okay. So you can just contact us as well. Okay. So let's start the webinar. So as a Midas, we have established our business in like 1989, and we are over like 800 plus employees and developers. Okay, and we have the number one market share in civil engineering software solution company. Okay, now as a if you see the Midas software portfolio, we have almost like a solution for each and every problem. Okay, so for the bridges, we have Midas Civil, which is our pioneer software. Then we have this Midas FENX for advanced nonlinear analysis. For geotechnical purpose, we have Midas GTSNX. And for the buildings, we have Midas Gen and Design Plus. Okay. So Midas Gen is basically the integrated system for building as well as in general structures. And Midas Design Plus is basically a component-based design, like which is basically it is a structural design tool for engineers. And then for BIM and CAD, we have Midas CIM and Midas CAD. Okay. So our headquarter is located in South Korea, and locally we are present in India as well, with our headquarter of India office in Mumbai and other two branches in Delhi as well as Chennai. Okay, and these are our global clients. So companies like Acom, Arup, Arcadis, Atkins, Jacobs are using our product in their day-to-day projects. And these are the some of the clients which are using our Midas Gen basically in India itself. So like companies like TCE, Sistra, Lombardi, Dar, Aegis, then like JW are using our product. And these are the basically the institute like IITs, NITs, which are situated to Midas softwares. And these are the government bodies. So the government bodies like BARC, IGCAR in Chennai, then like different PWDs, railway authorities are also situated with us. Okay. Now let's discuss about the application area. So in this Midas Gen is basically, I would say it is more or less a general software in which we can do all type of structures. It's not necessary that we can only do RC or steel. We can do both RC, steel, as well as composite structures as well. Okay. So other general structures as well, like plant structure or airport hangar or industrial structures also we can do. And in order to model these structures, we also provide some wizards which will help us to quickly model those structures. Okay. And like we also can do like pre-stressing as well as various types of nonlinear analysis is also there. So it will be like more or less like one-stop solution for the building as well as general structures. Okay. Now talking about the past projects which has been done using Midas Gen software. So one of the greatest milestone, we know that this the world tallest building. It has been used for column shortening analysis in Burj Khalifa. for Midas Gen. Then Moscow City Palace Tower, twisting 46-story building with composite columns. This is again used for column shortening analysis in Midas Gen. Then we have this Beijing National Stadium. So, like Beijing Olympic Main Stadium, they use this for steel optimal design and response spectrum analysis. So basically, we also provide an optimal design for steel structures, which will automatically optimize the whole structure as well. Okay, so like they use that basically function. And then if you want to do some masonry structures and all, we can do that as well. Not only this, like this Midas Gen software can be also applied in the industrial structures as well. Like if you want to do pipe rack analysis or a warehouse structure or any like silo or something like that, or any component of industrial building or something like that also we can do. Okay. And these are the some other projects in India itself, like Parul University, Gujarat, then Sai World City in Panvel, then Sky Lounge in Kalyan that has been analyzed and designed in Midas Gen software itself. Okay. Not only this, other than this, we can also do like underground metro station. Okay. Then machine foundation, and then this nuclear applications are also there. Okay. Talking about the capabilities, so we provide a very intuitive modeling. Basically, if you see like superstructure and substructure, both can be modeled into the single model file. Okay, so no need to go for a multiple software for these conditions. Okay, we can model them into the same model file, as well as we can also analyze and design them as well in the same model file. Okay, so yeah, and after that, like the modeling type for this Midas Gen will be like node and element based modeling, which will be like more or less same as STAD. Okay. Now the four major methods I would say which are available for modeling is first is the direct data transfer. So what we can do is like if we have any other software like Revit, Tekla, we can model the structure over there and just get the model from there to MyDestin. Okay. Then the second method will be the geometric based modeling. So this will be, I would call it as a manual modeling method. Okay. In order to generate the model, we have to define the coordinate of each point like that. Okay. Then we have this MGT command shell. So I think everyone will be aware about the text format of STAD, which is like in Midas Gen also we have same feature, which is called as MGT command shell. So with the help of some syntax, we can automate or uh, generate the model over here. Okay. Or if we want to do any manipulation as well, we can do them by using this MGT command shells. And then we have the wizards as well. So through which quickly we can generate the model. So I will show you this method as well for modeling. Okay. So as I said, we can model like we can transfer the data from like Tekla, Revit, STAD. Okay. So two-way link is there between Tekla and Revit. Okay. And then we have an import and export feature from AutoCAD as well, which I will be showcasing today. And then we have this IFC format, export to IFC format as well. And we also have for C structures, we have the Idea Statica connection file export function as well. Okay. Now, if you talk about the wizards, so what wizard will be doing is suppose if you want to model any structure, then we can just model it by just applying some basic data related to it. Okay. So suppose if we are modeling the truss, okay. So we can just go to the wizard option. We can click on truss and see which type of truss we want to apply. We can select the type of inclined members, define the length and height of the truss, and then we can increase the number of panels, how many number of panels we want in the particular truss. And then we can include the verticals. Here we can define the material and sections of the trusses. And then we can give the insertion point anywhere in the model. Okay. And when you click on apply, automatically the truss will be modeled. So in this way, we can generate the model quickly. Okay. And then this is the editor system of STAT. Okay, like that we also have this in our software, which is called as MGT command shell. So we can generate the load case and we can define the lateral load coefficients, load combination generation, user-defined lateral loads. If you want to generate these kind of application, we can do it over here easily. So yeah, and other applications are also there. And as well as if we want to generate the meshing for the slab, we have a very good feature which is called as auto mesh, which will automatically uh, like generate the mesh considering the internal node or internal element. If there is any internal element present in this particular slab, it will automatically capture those presence of that particular node or element. So meshing is quite good over here, as well as if you have any openings, or maybe like in case of flat slab structure, we have like column capital and this drop panels. This that can also be assigned. Okay. Now for the soil structure interaction, suppose as I said, we can model like superstructure and substructure both in the same model. So we have the various types of supports for the soil structure interaction as well. So if you see, we have the surface spring option over here. In case of mat footing, we can choose this type of footing, as well as we can also go for non-linear like definition of the springs as well, so that we can capture the uplift as well over here inside the software for the footings or maybe like mat footing and all. Okay. And for the pile as well, it will automatically generate the stiffness in the vertical as well as horizontal direction, which will be non-linear in nature, multilinear in nature, based upon the soil data and the pile data we will enter over here. So in this way, we can define the soil structure interaction. Other than this, like if you talk about like damper application or isolator application, we can do them as well by providing the general links over here. Okay. Then like we have this automatic application of seismic loads as well as wind loads. So I will be discussing in detail in the demonstration part for this one. So I'm skipping this one. And in case of underground structures, like automatically it can generate the earth pressure data over here based upon the soil profile which we will enter. Okay. So automatically it will apply earth pressure at rest and active earth pressure on the walls. Okay. So through this, we can analyze a retaining wall or any basement wall if you want to model in the structure. Like over here, we can model them. Okay. As well as in case of seismic analysis, if you talk about, like as we know that always our plan which we are designing or we want to model is not a regular one. So in that condition, what happens is we have to apply the response spectrum in the principal angle. Okay. So like over here in Midas Gen, those principal angle, suppose this is our principal angle. So it will automatically capture the present, like whatever the principal angle will be, and apply the response spectrum in that particular angle automatically when we go for auto search angle. Okay. And these are the analysis types which we can perform in Midas Gen. So if you talk about seismic analysis or maybe like dynamic analysis, we can do like free vibration or modal analysis, then response spectrum analysis, time history analysis, P delta, then linear buckling, heat transfer, and then we can also do like construction stage, pushover, inelastic time history analysis, and then various types of other analysis as well. Okay. So these are the some of the highlights basically: construction stage, pushover, masonry, then inelastic time history analysis, boundary nonlinear time history analysis, as well as post-tensioning. Okay. Now after this, in case of seismic analysis, if you are doing or like we have some recommendation for irregularity check as per 1893 and 16700, which is already included inside the software. So story drift check, story mode shape check, torsional irregularity check, stability coefficient check, then weight irregularity check, and like capacity weak story check. Those all checks will be automatically provided in the software. Okay. Then we can also generate the load combinations automatically based upon the IS codes. Okay. as well as we can also generate the load combinations based upon our like user defined load combinations as well. Okay. And as far as design is concerned, all IS code, latest codes are already implemented. So if you talk about RC structures, IS 456 and 13920 2016 is already implemented. Okay. For both like beam, column, and wall as well. Then for the steel sections, IS 800, as well as the new code, which is like detailing, tactile detailing for steel sections, which is like IS 18168. That is also implemented inside the software. Okay. As well as we can also do like isolated or a combined footing design and basement wall design and the shear wall design using Design Plus as well. Okay. Not only this, IS code, if some of the people are interested in the like other codes like American or Euro code that are also implemented inside the software. Okay. So it's not like only IS code will be available, all the codes will be available for us. Okay. Now, after the design, like we have this detailed report generation options. Okay, so this type of report will be generated. One will be the summary report, which we called it as a graphic report, in which like demand and capacity ratio will be given over here, and then like section shape and PM curve. This is basically for the column. So PM curve is there, then shear capacity checks. Okay. And then one is the detailed report in which all the checks provided by these provided by the software according to the code, following the code, which will be it will be mentioned over here. Okay. So like we can refer this basically this detailed report to check if the design is okay or not, as well as we can submit this to our uh, checker as well. Okay. Also, we can also do like slabs design inside the software, like which will be FEM based design. Okay, in which wood armor moment can also be calculated. Okay, and like if you see like flexural check, serviceability check, and the punching shear checks can be done. Similarly, mat foundation design can also be done over here itself. Okay. Now for the steel sections, as I said, we have the very good feature which is called as a optimal design feature. So suppose if you want to optimize some of the section, okay. So what we can do is we can, sorry, yeah, what we can do is we can choose this section and just click on change button, and then it will automatically optimize those uh, particular section and give the list of the section which can be applied uh, like in place of this particular section over here. Okay. So I think we are planning a next webinar for steel building as well. So in that we will be see this feature in detail. So I will request whoever are interested, please join that webinar as well. Okay. And after that, we can also generate this report over here. So inside the Midas software itself, the Microsoft Word will be open. And whatever the things we want to enter in our report, we can enter and we can save this one. And we can send it to the client. And suppose after that, some clients will suggest us the revision. And you will do this revision in the model, and accordingly analysis results and design results will be changed, right? So when we click on this regeneration option, automatically our report will also update it. So we don't have to manually update the report over here. As well as I said, we have this Midas Design Plus option through which, like for IS code users, we can do like RC structures, which is like slab design, the load based slab design, one way, two-way slab. Directly we can design if we know the load. Then beam column design. Quickly we can design this. Basically, we don't need to generate the 3D model in these cases. Okay. Then shear wall, footing, and then the basement wall design. Okay. And all other design is basically available right now for American and the European code user. But right now we working on this steel design feature to develop this for our IS code users as well. Okay. And recently we launched this combined footing design option. And yeah, and IS 18168 is already implemented. And in the upcoming version, maybe we will launch IS 1893 new part, which is currently in the draft position. As soon as the final version will release, we'll be launching that as well. Okay. Now jumping on to the demonstration quickly. So just for a quick introduction of the GUI of the software. So if you see, like for at the top, there is a main menu which has been arranged according to the workflow of the project. So the first four tabs will be related to the modeling. Then we will be having the boundary condition. Okay, so we have to apply the boundary conditions. Then we will apply the loads. So different types of loadings will be there. Then we can set up the analysis environment, and then we can see the results. Okay, so we can check the results over here, and then we will go to the design tab to design the buildings. Okay, and then we have the other tabs as well to see the utility of the model and all. Okay, and after that, if you see, this is the graphic view where all the whatever the things you will model, it will be reflected in the graphic format. As well as at two sides, we have the tree menus. In the workstream menu, whatever the things you have modeled, it will be reflected over here. So suppose in any conditions, if you want to know what is my edge section column, where it is present. So I can just double click on them and it will be highlighted in the red color. And these are the element number, okay, which has been selected. So like that. Now, sometimes what happens is if you want to change this interior column, sorry, edge column to interior column, you can just directly drag and drop after selecting those columns. So in this way, quickly we can edit the model, as well as we also provide the table format of each data, which is like input data, like data for the geometry or the loading in the tabular format. If you want to edit something or make the new data in the Excel, we can make them and just copy paste the data over here. Automatically, the model will be updated. Okay. Over here, we also have this message window. So after each and every analysis, it will give some message. If there is any warnings or errors in the model, it will be reflected over here. And at the bottom, if you see, we have this dynamic unit uh, converter option as well. So at any point of time, if you want to change the unit of the model, you can change it. Okay. So this is the basic GUI. So let's start the modeling quickly. Okay, so I'll show first how we can generate through the wizards. So if you see, we have this frame wizard option over here. Okay, so suppose in our plan, we have 5 bays in the X direction, in we having 5 meter distance and 4 bays in the Y direction, and the four like we have the repeated at the four. Okay, so I'll just add the X coordinate and the Z coordinate. So it will look like this. Okay. Then I will click on edit and click on generate frame. So the frame is generated. So in the similar fashion, whatever the plan of our building will be there of first floor, we can generate it over here and we can insert it anywhere in the model. Suppose I will the story height is 4 meter. So I'll generate it over here and I'll give alpha is 90 degree and just click on apply. So you can see this is basically our plan is now generated. Now I can exclude this particular node to generate the columns. Okay. So, but it is not necessary that almost like every time we have the regular type of plan. Okay. So what happens in that scenario is we can make the same central line of the beams in the AutoCAD and we can import that AutoCAD central line directly to generate the model over here. Okay, so let us go for that as well. Okay, so when we for that we can just go to this import option and just click on the AutoCAD DXF file. Okay, now here I can just browse that particular file over here. So this is my file, which is DXF import, and I'll just click on open. So here in this, whatever the layers, different types of layers which have been provided in that particular DXF will be highlighted. So we have to select those DXF which is having the center line of the beam. Okay, um, all other lines or layers we can neglect. Okay, Now here we can also generate the material as well as sections. Okay. So if we click on add, we have to just select the concrete and we can select IS code, ISRC, can select the code M30 suppose, click on OK. Then we can select the section as well for the beams. Okay. So I will go for solid rectangular user beam. Suppose height I will give 0.6 by 0.3 and click on OK. So we can also generate the different beams. Okay. And we can, after that, we just have to click on apply. So you can see quickly, we can generate the plan over here. Okay. Now, um, what we have to do is we have to uh, extrude the like this nodes in the Z direction to generate the columns. Okay. So what I will do is I'll go to this create element, extrude option. And in this, I'll go for node to line. I can select the section. Again, I can create one more section for the columns. Okay. So I'll click on add, solid rectangular, user type. Suppose my column size is 0.5 by 0.5. Okay. And I'll go for unequal distance in the Z direction, giving the distance as -4. And I'll select all the locations where I want to extrude the column. Okay. So like this. Okay. Here I'm not selecting it because I want to generate uh, the shear wall at this location. So I'm keeping it like that and just click on apply. So you can see it is the columns has been generated. Now to generate the shear wall, I'll just quickly generate one dummy beam over here. Okay. So I'll just generate one dummy beam over here and here, and I'll extrude this dummy beam in the Z direction again. Okay. So like there can be a different way of modeling, but I choose this one because I find this way of modeling very easy. Okay. So I can give the thickness as zero point 0.3, suppose 3 and click on OK. Equal distance in Z direction, which is -4. And I have to select these particular beams and just click on apply. Okay. You can see the shear walls is also modeled. Okay. Now what we can do is we have to apply the loads, right? So for the loadings, like I generally prefer if the floor is a typical floor. So I just first apply the load and then just copy the floor to the above story. So in that scenario, what happens is whatever the loads we will apply in this particular floor, it will also copy to the other floors. Okay. So like for that scenario, we can just generate the static load over here, which is like dead load, add, and the live load. Okay, we can add other type of load as well. If you see roof live load and wind load and earthquake type of load cases as well. Okay, so for that we can just go to this define flow load option and define the load over here. Whatever the name we want to give, we can give it over here. Okay, and here the dead load which we are applying. Suppose if you are going for a member in action, we are not going to model the slab in the Midas Gen. So in that scenario, whatever the self-weight of the slab, we need to give it over here as a dead load. Okay. And whatever the live load it is, we have to give it over here and just click on add. Okay. Now in this, after that, we can just go to this assign floor load option and we can select over here, like which type of distribution we want for the floor loads. It is like a two-way or one-way. And in the case of irregular geometry, we can also go for polygon centroid or the polygon length distribution as well. So we'll just quickly select this outer nodes to distribute the load over here. Okay. So currently I have defined the load. Yeah. So I can just click on apply. So you can see from the top, the two-way action has been taken here, and automatically the loads has been distributed to the particular beams. Okay. Now to apply the load of the infill walls, we can use this element beam option. Okay. And in this also we have the uniform load or a trapezoidal load, any type of load we can apply over here. Okay. So simply we just have to apply the value of the load, suppose minus zero point 0.5 is like we can select the dead load and select the beams over here. Suppose all beams, sorry, not all beams. Okay, suppose only this beam I am selecting. Okay, and just click on apply. So automatically the loads will be applied over here. Okay, now we just have to copy this floor to above story. So for that condition, we can use this built-in generation command. Okay, so over here I'll copy this for 11 times, suppose, and I'll give the story intermediate story height as 4 and just click on add over here. Okay. Now during the copy, if you want to change the material or column section size, we can change it over here because as we go upside, the column section can be reduced. So those kind of assignment also we can give. Or else if you want to like change the uh, story height also, we can do this as well. And we can just click on OK. And over here, we'll just select this particular model and just click on apply. So you can see this, how quickly we can generate the whole building. Okay. Now after that, we will apply the seismic load. So for the seismic load, if you see, this is the same model which I have generated. Okay. Now if we go for the loading, first thing which we need to define is the load to mass option. Okay. So for that, we can go to the structure tab, and here we will go for the structure type, and I'll check on this convert self weight into the masses option in the XYZ direction. And after that, we have to go to this load to mass option, which is also called as mass source in various software. So where we can go to this load to mass, we can select the direction and apply the scale factor according. Okay. So according to the code, whatever the value for the live load and dead load we want to provide, we can apply. Okay. Now after that, like we can also apply the wind loads as well over here. If we talk about like tall structures, we can apply both like a standard method as well as dynamic method as per IS 875 2015. So standard method and the gust vector method both are available inside the software. But for today's session, I'll keep it like I'll not discuss this part, wind load part, but in the coming sessions, obviously, yes, we will going to discuss this in detail. Now coming on to the seismic load, okay. First, we have to just click on add button, okay. And then this tab will be open where we have to select the code, which is IS 1893. We can provide the various parameters, seismic zone, soil type, importance factor. And then for the period calculator, we have option of automatically calculating the period based upon the formula given on the code. So according to our structure, we can select which formula we want to go for, or else like we can also provide our own analytical period as well. It's not necessary or always you have to select a formula from here. Okay. And as well as we can also edit the height. So this is automatically generated height by the software, but we can edit this as well. Okay. So accordingly, we can provide the periods like fundamental period and then the response reduction factor. And then like if you are applying in the X direction, we can give the scale factor in X direction. And if you want to consider the accidental eccentricity, we have to select the positive one for X direction. Then we have to again make another case for the negative direction in the X direction, similar. So in this way, we have to generate the four cases for earthquake. like static earthquake. Okay, so like that, I have already implemented the four cases over here. So if you see, this is the it is the case for the y direction, which is having the positive accidental eccentricity. Okay, so in this way, we can generate the static earthquake. Now talking about the next part, which will be the dynamic load, which is our response spectrum. Okay, for the response spectrum, again, we have to just click on add. Then this will open. We can go to this design spectra. And over here, we have to select the code. So as soon as we will select 1893, we can provide the seismic zone, soil type, then again, what response reduction factor, importance factor. And when you click on OK, automatically the response spectra will be updated over here. And this is already a normalized spectra. We don't have to scale up this after that. Okay. So over here, this spectra is also editable, is in the editable format. So if you want to generate the vertical spectra, also we can generate over here. Okay. Now let's go to this next part. After generating the spectra, we have to define the keys, right? So for the RX, I just type the name as RX and giving the excitation angle as 0. Okay. And after that, we can just click on add. Similarly, for the y direction, I can just select the excitation angle as 90 and just click on add. And after that, if you want to apply in the z direction, you can just click on z and click on like select the z direction spectra over here and apply it. Now, before running the analysis, we also have to taken care that eigenvalue analysis control has also been applied. Okay, so if you click on this eigenvalue analysis control, we can select which vector we want to go for, or eigenvector or risk vector, both method are there. And number of frequency is like number of mode which we want to consider. Okay, now after the end, like almost like we have applied all types of load. Okay, in case of various projects, like in case of high-rise structures, we can also go for this time history analysis as well. Okay. Yeah. And if you see, we have the other type of loads as well, like pre-stressing, moving load, or the construction stage load, which is like useful for column shortening. Those are also available. Okay. Now I will go for the analysis results. Okay. So in the result tab, we will go to, like other softwares, we can also check like reactions, forces, like beam diagrams and all. Okay. So if you want to check, suppose beam diagram for static case, static seismic case, you can just click on apply, and I can just click on deform option as well. Okay, we can choose like from which angle we want to see this particular floor. Okay, this can be also animation, animate, as well as we can save this as a TXF format as well. Okay, so you can see this is the maximum value and the minimum value, and whatever the element which is having the maximum and the minimum force. Okay, so similar to that, we can check the deformations, the actions as well. Now talking about the vibration mode shape, because that will be the major part when we are doing the seismic analysis. So suppose this is my first mode. I think it will be going in the X direction. Yes. So 82% is participation in the X direction. So you can check this. Then the second mode, suppose we want to check, which is in Y direction, which is almost like 70% participation in the Y direction. And suppose if you want to see the animation view, we can see the animation view as well. Like, because if it is, we will see the animation view, the visualization is also very quick. Okay. Now, if you want to see the tabular result, you can also click on this three dot button and just click on OK. So this is basically the time period of each mode. Okay. The 10th mode that we have considered. And then this is basically the modal mass participation factor for each mode. Okay, so you can see first mode is in the X direction, the second mode is in the Y direction, and the third mode is in the Z direction. So almost like the behavior is correct. Okay, now we can move on to the different options. Okay, now the different options which are over here is basically I would like to show you this option, story share force option as well. So what it does is basically it will give you the highlight how much story share is taken care by the each floor in each floor by each column and the walls. Okay. So sharing of the story share can be visualized over here. So I will go for story share in the Y direction and just click on apply and I'll go for the ratio. Okay. Okay. So it can be seen that almost like most of the columns are taking the most of the story share. Okay. And these results can also be checked in the story tabular format as well. So if you see over here, the various types of story checks are also available, which will be necessary in the case of the seismic analysis. After we do the seismic analysis, we have to check this. Okay. So if we go for first, we have to set up the check parameter, which will be according to IS 1893-2016. And we also have implemented IS 16700 as well, which is the code for the tall buildings as well. Okay. But today we'll discuss more about 1893 as well only. Okay. So first we'll select the check parameter and the irregularity check parameter, which is IS 1893. Okay. Suppose if you want to check the story drift, you have to just go to the story drift option. You can select the code, like from which code, which load case you want to see. Suppose for the RSX, and I'll define the vertical load combinations. And here we can define the other parameters as well. And I can just click on OK. So after that, the story drift will be available, okay, for the each floor in the combined in the X and Y direction as well. Okay. And after now the other checks are also available. So suppose if you want to check like torsional irregularity check or a weight irregularity check, for example. So you can just click on this weight irregularity check for ESX and click on OK. So it will check the story weight ratio of the particular floor and the lower story lower story weight. And if it is less than the 1.5 times, then it will be regular. Other than that, it will show a irregular option over here. So in this way, we can check the weight irregularity check. Okay. Then we will check like this torsional irregularity check as well. Okay. Suppose for the RX X, yes. So it will give you the average value of story drift in the extreme point and the maximum story drift value, and it will check if it is okay or not. Okay. So in this way, it will also give us the remark that if it is a regular or a irregular type of structure. Okay. Now, according to this results, we can change the plan or something. If it is going to be irregular, we can change it and we can provide the sections. Okay. So in this way, result interpretation can be done for the seismic analysis. Now let's discuss about the design. Okay. So for the design, basically, suppose if you are designing this particular structure, which I have already made it, like by defining the IS code implementation. So for that, first option we need to go for is design code. Okay. So we'll select the design code. We'll select IS 456-2000. Okay. And if you want to apply our seismic provision, we have to check on this option over here. And then like we have to select the code, like which code we want to follow, like IS 13920-2016. And I want to consider the strong column and weak beam ratio as well. Okay. If you want to consider the strong column weak beam check for the last floor as well, we can select that as well. And suppose in some scenario, if you are designing a mat foundation, then we can enter the factor of safety of soil over here and the modulus of separate reaction over here. And if you want to also do like torsion design for the beams, you can check on this option as well for RC structures. Okay. Now after that, like in the software, we have the two options for the design. Basically, one is the concrete code design and one is the concrete code check. So in the design, software will tell us like how much reinforcement we should provide in order to safeguard whatever the loadings that are coming. And then like we have the concrete code check option as well. So in this, basically, in the check, what software will do is we have to provide our own reinforcement, and software will check if this is fine or not. So in this way, these two options are over here. Okay. So like we can go and run the beam design, column design, and update the rebars. And accordingly, like sometimes what happens is inside some types of reinforcement are already present. Like suppose only P20 rebar is present. So we can modify those rebars and again just click on check button to check if that rebar is okay or not now. So like that also we can go. Okay. Now I will just directly run this ductile design in which automatically the beam design and the column design will be directly run. Okay. So after this, this kind of uh, like table results will be generated. So this is the summary for the beam design. Okay. So suppose if you want to check any results for this one. So if something is highlighted in the red color, that means it is going to fail in some of the criteria. So we need to check that criteria. Okay. Suppose if we click on this graphic button, so the details will be given like I and mid and J and whatever the rebar we have to provide. And I think it is failing in the pending criteria, like the flexural criteria itself. So shear criteria is okay. So accordingly, we have to take step to safeguard this in terms of the flexure. Okay. So in this way, we can check. And suppose if you want to check the detailed report as well, so we can check the detailed report over here. So this is the detailed report if you see. So all the detailed report will include all the checks which is given as per IS 456 as well as 13920 as well. Okay. So first of all, the section data will be given. Okay. And then it will check if the section size is okay as per IS 1893 13920 clause number 6.11. Okay. And then it will start the design. If this clause is not following, the software will not design that particular beam and give us the warning that this particular section is lesser than the code, whatever the section code is defining. Okay, then this is the like positive bending moment capacity check. So if the provided rebar is okay, it will type it as a okay. Okay, then this is the neutral axis finding, and then the shear capacity check, and all the checks as per uh, ISO 56 will be done. Okay, so this is for the beam. Now let's check for the column as well. So for the column, if you check the graphic report, like I showed you. So this is the graphic report for the column. And if you want to check like a 3D PM curve, that is also available. Okay, for the columns, basically PMM interaction can also be seen over here. Okay, and if you want to check the detailed report, you can go to this member option and just click on the detailed report. So for the columns as well, we will see the detailed report over here. Okay, so similar to all what we have seen in the beam design, all the checks will be reflected uh, over here in the detailed format as per 456 and 13920. Okay. Now, after this, we can also check like strong column, weak beam ratio over here in the table format as well as in the graphic format. Okay. So I'll go for the graphic format and I'll just apply all the button. So these are the ratios in the counterclockwise and the clockwise direction, like the beam strength and the ratio over here. And it will also give us the remark that if it is okay or not. Suppose if you want to check in any other angle, you can change that as well. Okay. So suppose if is some for the some load combination, if it is failing, it will also highlight that it is failing in the sum of the criteria. Okay. Now also like I missed some part that we can also define the load combinations as per IS code. So if you see this over here, you can go to this concrete design. You can generate automatically the load combinations. Just have to select the IS456 and whatever the scale up factor for response spectrum, we can provide it over here itself. We don't need to go for uh, basically we rerun the analysis after providing the scale up factor. Okay, and you can just click on this like if you want to apply orthogonal effect, that can also be seen, and you can just click on OK. Okay, and sometimes what happens is like while modeling itself, we can check the results for these static seismic cases without running the analysis. So suppose if you see, I'll just go to this properties. So I'll just unlock the model first. Okay, and I'll just click on these properties. So for the static seismic case, we don't need to run the analysis to check the base shear. We just have to click on this seismic load profile, and the load profile will be automatically generated over here. Okay, and if you click on this make will load seismic load calculation sheet, automatically the load calculation sheet for seismic static seismic will be generated over here, which will be in the detailed format, like whatever the factor we have considered and whatever the force that has been generated. Okay, this is the mass table for each floor. So in this way, we can quickly judge this particular static seismic loads, and like quickly, if you want to change something based upon this, we can change it over here. Okay. So yeah, coming back to my presentation. Okay. So not only this, like we also provide like with the software, we also provide the technical support through mail, or we have the GTC technical team over here. Like we can directly go to GTC portal, like internet portal, and raise your queries over there, and we will be answering them within 24 hours. And we have the design guide and the online help manual for suppose if you want to know something about software, we can know it over here, as well as we will give trainings and expert webinars like this, and like continuously we'll be having these webinars now. And like suppose if you want to ask something about your project, you can just directly raise the queries over here. Okay, and we also have this academy as well, where we can learn the step-by-step procedure how we have to design the building. Okay, so yeah, and this is the next schedule for the upcoming webinar. So today, as we see, we have done for the seismic design of RC building. The next webinar will be scheduled near to March first week or February last week, which will be for steel warehouse design as per IS 18, IS 800. And then we will be also discuss about the implementation of the seismic detailing code for the steel structures, which is IS 18168 2023 in Midas Gen. And the next few webinars will be like for the underground structures, foundation design, and advantage of using Midas Gen software for tall structures. And I will like we will also discuss about tips and tricks of modeling in Midas Gen. And at the last, we will be having the dynamic analysis of water tank in Midas Gen. Also, we will add some few more topics in this based upon the input from our attendees. Okay. So thank you. If you need any technical or any inquiry, you can just directly raise a query to me, which is my email is highlighted over here, anmol@midasit.com, or else you can also raise the query in the another email, which is for the Jayesh @midasit.com, or you can directly use our support site as well. Okay. So thank you. Now I am open for Q&A. So you can just raise your questions in the question box, whatever the queries you want to ask, just ask us. Okay, so there are some questions already. So I would like to ask them, sir, how can I learn the Midas software from basics? Okay, so basically, like we have the webinars like that, as well as we have some basically the YouTube video, and as well as we have the academy as well as I discuss, like Midas Academy, in which all step-by-step procedure is given over there. So you can just go over there and learn the software over there. Okay. Yes. So another question is, what about the diaphragm locations and like center of mass and center of rigidity? Yes, we will get in these, we will get these results over here. If you go for this story data and you will see the story eccentricity option, there we will be getting the center of mass and center of rigidity or center of stiffness over here. Okay. Yes, we will get the recording of the session. Okay. Can we design shear wall? Yes, we can design the shear wall over here as well. And like we can also follow the recommendations of the IS 13920 as well. Yes, like there is a check for the axial stress for the column as well. Okay, someone has asked that question. Yes, so there is one more question, like if we can do the machine type of foundations or not. Yes, we can do this machine foundation as well. So if you see for machine foundations, the loadings will be like we can go and run the time history analysis over here. We can generate the sinusoidal functions, okay, for the machine types for simulating the machine type of loadings. We can simulate the sinusoidal loadings and do the machine foundations as well. So basically, we have the very good option for that. Yes, we can import the STAT as well as ETAP model over here. So someone has asked, like, can we do precast structures and do the analysis and design? Yes, we can do like the modeling will be almost similar, which we are seeing over here. Okay, and we can do the analysis and design over here. Okay, so one more question is, can we do temperature loadings or not? Okay, so yes, we can do this temperature loading. So if you see this, we have a temperature and pre-stress option in which element temperature and beam section temperature can be provided. So basically, like if you have a gradient temperature as well, we can provide it over here. Okay. Yeah. So someone is asking that is there any student license? Yes, student license is also available. We can do that. Yes, so one more question is like, can we do pre-stress concrete beam or girders? Yes, we can do this pre-stressing as well. So if you see this option, pre-stress load, yes, we can do this pre-stressing as well. Ah, okay. Yes, so one more question is the section designer is available as like in ETAPS for the retrofitted section? Yes, the section designer is also available over here, which is called as Midas GSD. Can we design the foundation? Yes, we can design the foundation as well. Like we have a webinar for the foundation design as well. We can directly uh, join that webinar to get more detail on that. How do we get the student license? So you can directly mail us on my email address or another email address which I mentioned, jayesh at the rate medasIT.com, and we will be providing you the student license as well. Okay, can we incorporate soil structure interaction with Midas Gen? Yes, we can do soil structure interaction, and we also have a great interlinking between the soil software, which like geotechnical software, which is called as Midas GTSNX. And like with that, we can do like very good interaction between the soil and the structure. So it will be very good. Can we design water tank? Yes, we can do this water tank as well, as we also going to have a webinar on that part. So yes. So there is one more question from Dr. YK Guru Prasad. In concrete damage plasticity used in concrete material model as it is yes, as it is in the civil, Midas civil. Yes, the concrete damage model is also available over here. Okay. Cyclic loading in Midas. Okay. So cyclic loading can also be simulated through time history analysis. Okay. So as I said, we can generate the sinusoidal loadings and we can simulate the cyclic loading over here. Okay. Can we do detailing? As of now, detailing, as someone has also asked, like we can have the RCDC connections or not. So as of now, my question will be no, but yes, soon it will be releasing. Okay. Can we do finite element analysis of masonry wall? Yes, we can do this finite element of analysis of masonry walls. And like for the masonry structures, we also have this basically a very good option for doing the plastic analysis as well, where we can define the plastic material for the masonry structures. So if we go for this plastic material property and click on add, so if you see this masonry structure, like masonry model is also available, like plastic model, as well as someone has asked about the concrete damage. So that is also available. Okay. So I think all other questions will answer you through this, through our, you can directly contact us. And thank you all for joining today. We are pleased to have you here. And I hope you all will be again joining us again into the next webinar, which will be on sea structures basically. Yes. So thank you.